Hi team, happy Friday. I hope Wednesday went amazing. If you emailed me, I probably emailed you back by now, and I've also answered any of your online questions. I'm going to skip an introduction problem because the problems today are exactly the same as the problems from Wednesday, except now instead of no calculator, we're using a calculator. So the idea is that functions over a time get more challenging and more challenging, and we have graphical software that will graph it for us, and then we use the graph to interpret whether we're increasing, decreasing, so on and so forth. So here's what you're initially going to do. If I give you a function, you're going to put this in y1 in your calculator. Followed by, in second portion, you're going to put in the first derivative, and third, you're going to put in the second derivative, meaning the derivative of your first derivative. I'm going to show you how to do that using an example, and then we're going to talk about what exactly you're looking for. So your goal is to, again, graph, and then use this graph to determine increasing, decreasing, concave up, concave down, whether you have critical values or you have inflection points, and to use the calculator to determine those specific things. So we're going to use this as our example, x to the fifth minus 5x to the fourth minus x cubed plus 28x squared minus 2x. And I'm going to do all this stuff with this example. So I have my calculator here. I'm going to have to turn off my light so that you guys can see my calculator. Okay, so here it is. And I've already entered it in so far. Like I've already entered it. So what we do is in y2, I'm going to put in the first derivative. So if you recall, it's under the math button. And under math in number 8 is the n derived. So you can scroll down or you can just hit the number 8. And it ends up like this. So we say d over dx, and then we do not put in the equation again. We do alpha trace, and we put in y1, and we want it everywhere. In addition, I scroll down, and I can do it again. I'm going to put in math down to number 8, d over dx, and then this time I'm going to select y2 because it's the derivative of the derivative. So I'm going to hit alpha trace, and I'm going to select y2 this time, x equals x. Now I caution you putting all three on the graph at the same time. So what I do is I scroll back, I hit enter, and on y3, and I scroll up and hit enter. So now the equal signs are not highlighted. That means that it won't actually graph it because I want to actually see the graph as a whole first. So I'm going to hit zoom standard, that's zoom 6, and this is what I see. That's pretty crazy. So I would really like to be able to see this in a better window. So what I'm going to do is I'm going to decrease my window on my x's, and then I'm going to increase my y's and see what happens. So I'm going to go to my window, and let's do -5 to 5 because I'm not sure what it's going to be yet. I'm not sure either what my minimum and maximums are going to be, and so I know I need to increase them, I just don't know by how much. Let's just do -1, y min, let's do -100 and then 100. Just see what happens. So then we hit graph and we see what it looks like. Goes up and cool. So it goes up, down, up with a little curve, and it keeps going up. If you were concerned about something that happens up here, you could go back to your window and increase your maximum if you like. I'm going to do that, just see how it changes. And it didn't change it all that much, so I'm now seeing everything that I'd like to see. Now, I'm going to decrease my X window over here a bit. I'm going to change it to -3 instead. And that way I have it filling up my entire screen. So what I'm going to do on my paper for my homework is I'm going to draw a sketch of this. And I know that it's going up and then it goes back down. I'm not sure if it crosses or not. And it does something to this effect. So I know I'm going to have a variety of, I have a max, I have a min, I maybe have something going on right here, I'm not sure. And then I know I'm going to go to a -infinity to a +infinity. So then I'm going to now put on my first derivative. So I go back to my y equals, down to number 2, I'm going to hit enter on my equal sign, and I'm just going to hit graph. So that one's already painted, and then there is my first derivative. There you go. Okay, so here's what I'd like you to see. I'm going to write that this is f of x. And I'm going to come over here and I'm going to sketch roughly this. So it does this, it goes up, and I think it goes under like that and does this, something to this effect. Now we know that this would be an x to the 4th, right? Because this is an x to 5th and this is f prime of x. So if I were to be able to highlight some of these things, I now know that from this point to the left, that is a positive value, so I am increasing in this space. Then I am also increasing from here to here. And then something weird is going on here, and I still don't quite know what's happening. Sorry, I moved it down. It was hard to see. And then somewhere over here, I'm going to be increasing again. Increasing. Okay, so that means that in these other locations, I'm going to be decreasing. So your first job is you need to find these critical values. I somewhat witnessed 4 of them. My y value seems a little bit much, so I'm going to go back to my graph. I'm going to change my y value. I'm not sure what I should change it to, maybe negative 50 to 50. Go back to my graph and see. There's my original function, right? I can't see this top portion, but I'm really concerned about my derivative. So here it goes down, it goes back up, and then it goes back down, and I do see that it looks like it goes all the way. I'm going to change my window one more time. Let's make it, gosh, I really care about just the zeros, so let's do negative 5 to 5. Now your function is going to look a lot different, but you really have your range that you're caring about, I'm sorry, your domain that you're caring about. Here's one of the zeros, there's another 0, and then it's going to come back down eventually, and look, it does go below. So now your job is to find all of those locations. So I'm going to write here critical values. So on my calculator, I have to go to second calculate, and I'm calculating a 0. If you notice at the top, I'm at y1. I need to hit the down arrow key so that I'm at y2 because I care about these zeros on the first derivative. I'm at x equals 1, which is somewhere here. I'm going to find this very far left one first. So I need to hit the negative. I'm somewhere past negative 1. Somewhere. Oh, look. Okay, so that means it's just jumping really large. I am on the left. Now I am on the right. And I get x equals, oh, I want to guess. Wow, where'd it go? Oh my goodness. Okay, so I'm going to go back. Where's my graph? Second calculate, 0. Let's just do, I know I need to be a little bit more to the right. There we go. No sign. Oh, I was on my original function again. Oh man, make sure you're on your derivative. Okay. There we go. There we go. Negative 1.499, which is approximately negative 1.5. Okay, now I'm going to keep doing that. I'd like you to hit pause, please. Keep doing that and find all of your values. All right, you should have found now all of your values. They're approximately 0.04, 2.62, and 2.84. And remember, this is on your red function. And as you saw, you must be careful about what function you're actually looking at when you're calculating these. So these things are all of your critical values. So if I'm asking you where is my interval increasing versus decreasing, I can now make those judgments. So let's do increasing first. Increasing should be from negative infinity to this first critical value, negative 1.5. My second section is from my 0.04 to my next critical value, which is 2.62. And it's in that last section, my 2.84 all the way to infinity. So I have multiple locations of increasing. Decreasing, I have 2 intervals, so between the first 2. So that's going to be, I'll scoot this up for you guys. That's going to be negative 1.5 all the way to 0.04. And my second one, which is my 2.62 to my 2.84. So those are my 2 locations there. All right, if I were actually finding the max and min values, so what my max and min values actually were, I could do that as well. because I have seen my function overall, and I know that these are where my critical values are located, going back to my original function, I know I have a max here, right? I know that I'm going to have a min here, but I know that whatever is happening in these locations, I'm not quite sure. Like, you need to be careful with these and actually calculate them, right? Because there's something going on in this space. So you have your 2.6 and your 2.62 and your 2.68. So your 2.62 is more than likely to be a max, right? Because it's going to go up and then it goes down just a little bit, and then this one's going to be your min. You could find all of those values. So I would second quit. I could go to my second trace, y1. So I want in my original function, I'll show you how to calculate all the values at once. I hit a parentheses and then I hit second parentheses, which gives me a French bracket, and I can enter all of them at the same time. Negative 1.5, comma, 0.04, comma, then you have your 2.62, comma, and your 2.84, and French bracket and your original, and then here are all my values. You could then obviously write those down, scroll back and forth, do all the things that you would need to do. Okay, so now for the next one, your f double prime. Now I'm going to turn off this one and I'm going to turn on this one, and I'm just going to hit graph and see if this graph is appropriate for my window. Okay, so I'm obviously thinking, right? I have a spinning thing up in this right-hand corner. It is clearly thinking about what to do, and there they are. I can't see it all that well, which is not helpful. So I'm actually going to, once it's done thinking, I'm going to change my window because I can't see it very well. It went up, down, and then back up. So I'm going to go back to my window. Oh, it's still thinking. Oh, goodness gracious. So I'm going to go back to my window, and I'm just going to, I think I'm going to leave it at -5, but I think I'm going to go up to about 100 and see what happens. So I'm going to go back to my graph. Okay, so here's my original function. And then now it's thinking again, right? So we have to wait for it to calculate the second derivative. And then here it's plotting its values. So it's going up. It's going back down. It goes underneath the axis. And there it goes back up. Now, you should understand that f double prime of x is going to be some sort of cubic, right? X to the 5th, x to the 4th, x cubed. So you know that your function is doing essentially this, right? Your second derivative. Okay, but now essentially you're doing the exact same thing that you were doing before. You need to find the critical values of f double prime, which is your zeros. Now I can't see my zeros all that great. I'm going to go back to my window. I'm going to change my y min. I'm just going to make it, let's say, -50, just so it's a little bit easier for me to see. And you're going to do the exact same process, okay? You're going to do second trace or calculate. You're going to find the zeros, and you're going to make sure they are of this particular quality. Will you please press pause and complete this? Find all the critical values / inflection points, and then check your answer after you press play again. All right, so you should have -0.89, 1.15, and 2.74. That is here, here, and here. Now from there, you should see your intervals. Okay, the two intervals that I just located, are f double prime values are below the axis, meaning that those two sections are negative, and therefore they are concave down in those spaces. Followed by, in the other two sections, these are positive x double prime values, so that means this is concave up in these two sections. And again, you can label those concave up, concave down, and describe those intervals for me. So you should have a concave down in the following sections. -infinity to this first location, -0.89, and here, which is 1.15 to 2.74. Then your concave up is going to be between -0.89 all the way over to here, which is your all the way over to your 1.15, followed by this last section, which is your 2.74 all the way to your infinity. So you should be able to label those intervals now as well. All right, last thing that you should be able to do is find, obviously, the extreme values. If you wanted to plug in and find any of these the relative maxes or mins, recall that in your calculator, you would be going to the original screen and doing things like this. In addition, if you wanted the exact output values of your inflection points, you could, again, do the same. You just plug in different values there. I am not going to do any more examples because, again, you guys know all of this information. It's just using your calculator now at this point. You have homework. Please complete that homework, and you can always do extra problems out of the book. Should you have any questions, please let me know. Both sections that I was gone for, 4.5 and 4.6, they are essentially the same thing. One is using a calculator and one is not. Good job, you guys. Keep up the good work. Next week, we will be doing 4.7 and 4.8. We're ending chapter 4, followed by you have Thanksgiving, and then we have our midterm on that Monday. So be ready, and hopefully you are studying. Have a great weekend, everybody. Bye-bye.